So we're now going to look at a formula for infinite series. Let's express this as a proposition. So say that AK and BK are infinite series. So they have to, well, let's start at 0. It doesn't really matter. So these are two infinite series that converge, meaning that the limits of their partial sums both have a finite value. So both converge, meaning that the limits of their partial sums both have a finite value. So if this holds, then I can take AK plus BK like this and add it, and then expect to get the same if I add the AKs separately first and the BKs separately afterwards. So this is a type of associativity for an infinite sum. So how to prove this? Proof? Well, basically here, the point is to realize that this is true for finite sums, and then use the limit to infinite sums, okay? So to infinite series. And for finite sums, well, so first, let's see what happens when you just sum one term here. So is this equal to this thing here if I just sum this first term, the 0th term? Well, this guy here would then just be A naught plus B naught. Parentheses around him, parentheses around him, doesn't matter. And then this guy would just be A naught plus B naught. And clearly, this is true. There's nothing to prove. In the same way, I could write out when I sum from k is equal to 0 to 1, and then notice that the left-hand side is equal to the right-hand side. I just have to use associativity once or twice to prove this. And then you can kind of generalize this or push it further and use induction to show that this formula here has to hold if, so I don't want to write everything again here, so let me just adjust it. So you can use induction to show that if I put an n here, an n here, and an n here, all is fine. So this is a very kind of short induction argument. So I won't do this here. So the point here is to figure out how to connect this to the infinite series. So maybe I write here, true by induction. So, and now's the question, what to do to prove this? Well, we use the definition of what an infinite series is. So I can start out with either the left-hand or right-hand side. So let me write out the left-hand side up here. And now we're going to try to find a chain of equalities connecting these two sides. So my first step is just using the definition of what this means. So that is that this is the limit as n goes to infinity, where I take the nth partial sum here and then sum up these guys. But now I know that this is true for every finite n, right? This is what my induction argument would give. So I can here use this to replace this thing here by this thing, where I now put in the summation limits like this, okay? And what happens next? Well, next I can put the limit onto this guy and the limit onto this guy. And now I'm using a rule for the limits here, that the limit of a sum is equal to the sum of the limits. This is not always true, but it is true if each of the summands converge separately, which is the case here. Now, but now by definition, this thing here is the value of the infinite series of the a's. And similarly, this is by definition the value of the infinite series for the b's. And we are done. So the point here was to start out with infinite series, pass to this expression with the limits, because here we have finite sums, then use the fact that we know the formula holds for the finite sums, and then use a rule for the limit where we can pass the limit to each of these guys. And then finally, we use the definition again to pass here and here.